Okay, so this session I'll be talking about Docker. So this will be an introductory session. So the agenda will cover the basics of containers, and then we'll talk more specifically on Docker, which is a containerization tool. From there on, we will continue working with Docker images and containers. I will also talk about customizing data in Docker containers. We'll try to build our own Docker image, and like Robert mentioned, I'll be doing a presentation on Kubernetes in a couple of weeks. So where did the concept of containers come from? So have you ever been in a situation where you had to install a software, let's say Oracle? Now, even before you venture into installing Oracle, you have to go through the prerequisites manual, which typically is larger than the actual installation manual itself. Even after you follow all the steps, sometimes you run into issues where the software doesn't work as you thought it would. Now, containers are related to virtual machines. So let's start with virtual machines. So everyone is probably aware of virtual machines. You've probably created virtual machines with Hypervisor or VMware or any other tool in the market. So there are a lot of tools out there today that allow you to spin up a virtual machine. So in the previous example of installing Oracle, say if someone gave you a virtual image of Oracle, all you have to do is run that image and you're good to go. So that is the concept of a virtual machine. Now we could take a physical host, like my laptop, and run this virtual machine on top of it, and then you're good to go. Each virtual machine, by virtue of its characteristic, is an entire operating system by itself. So designers try to mimic a real operating system. Sometimes it can be an overkill. Say you want to run a very simple application in an isolation mode. This concept of having a virtual machine can be resource intensive. Virtual machine also mimics a real operating system, so factor in the startup time and shutdown time. Although it's considerably less with the tools out there, nevertheless it still goes through the boot up process, etc. Also, say if you're a developer and you have a laptop with about 16 GB of RAM, by the time you start your fourth virtual machine, your laptop is going to be slow as hell. So there was a need for isolation, but also a need to optimize the approach to make it better. So what containers did, by contrast, it leveraged the operating system already in place. So it simply uses the host operating system. So this results in a very low footprint. So each container will have as close to as possible isolation as a virtual machine, but it will not have its own operating system. You're just going to have a container engine that runs on top of your operating system. There are no guest operating systems, so container is not going to have its own dedicated operating system. This container simply has everything you need to run your application. So that's all it has. It just has everything you need to run your application. So if you really think about it, what does an app really require, right? So the app requires some kind of a runtime system, some libraries, some resources. That's all the app requires. But an operating system provides like 1,000 different things. There are 1,000 different things in an operating system that your app will never ever use. So container counts on that logic. So we are only going to use whatever is required to run that app, a handful of files, some calls to the operating system. You don't need everything that an operating system provides. So container is only going to be a wrapper around your app with only the stuff that is required to run that app, and that's it. And it's going to run in isolation mode. And this results in a lot less memory, a lot less resources. So containers has a very, very small footprint. You can run quite a few containers in your laptop without your laptop ever slowing down. And the other advantage of containers is that it is portable. Because it has a small footprint, you can easily move it to another cloud. So you have a container running on your laptop, and you wanted to run it on the SAP Cloud Platform, Microsoft Azure, Google Cloud. You can easily port it, and it's one of the advantages of containers. So in summary, what is a container? It is a lightweight alternative to virtual machines. Can it do the same level? Can it provide the same level of isolation as a virtual machine? Yes, almost the same level of isolation. There are some things that a container cannot do, but in those cases, you just have to architect it slightly differently. So lately, I've been playing a lot of chess, so I thought I would create an analogy with chess. Say you need to arrange a chess game. So a virtual machine is similar to building an entire house where the table and the chessboard resides. Obviously, the house provides a lot of amenities. It has a kitchen, it has a bathroom, it has a bedroom, a living room, and so on. But if you really think about it, does the chess game require all those amenities? For the most part, no. So a container, by contrast, it simply has the table and the chessboard. Everything that is required to play this chess game, hence a very low footprint and very portable as well. So you can move the chessboard and the table anywhere you want. So what is Docker? So a lot of people use the word Docker and container interchangeably. Actually, container is a technology by itself. It is an ideology, a philosophy. Think about it, yeah. But Docker happens to be the leader in open source containerization platform. It's free. It is Linux based. Docker containers are easily moved between environments. So there's a lot of times developers have heard this phrase that it works on my laptop, doesn't work on your laptop, because some prerequisites are missing. But with Docker containers, you have everything you need to run that application wrapped up as a single unit. You can run it on top of any container engine. So you can run it on AWS, Azure, or your laptop or my laptop. So just a quick comparison. A Docker is the size, the footprint is so much smaller than a virtual box, which is a virtual machine. The startup is so fast. I mean, you can start virtually like 10 containers within a second. Whereas with virtual machines, there is the boot up process, so it takes a little while. Integration, portability is so much more easier with Docker because it has such a small footprint. Some terminology that you would need to know when working with Docker. So the first thing that I would like to talk about is images and containers. Now, an image is like a file, so snapshot of a container. So even with virtual machine, you may have a virtual machine image, which is a file. So similar to that, a Docker image, essentially it is a snapshot of a container. It's just a file. Now, you can spawn multiple copies of this Docker image. So you can take an Nginx image. You can download an Nginx Docker image, and then you can spawn, say, 3 or 4 instances of that image, and each instance that you spawn is going to be called a container, a Docker container. And this Docker container runs on top of a Docker engine. And the Docker container can either be in stop or in a running state. So a Docker container, nothing but a running instance or an instance of an image. And I'll quickly talk about port mapping in Docker, and then we'll go to like a live demo, and then to illustrate the Docker principles. So you have your operating system, and on top of your operating system, you install this Docker container engine. This allows you to run any Docker container in your laptop. So you have your operating system, you install the Docker, the container engine, and then you have a container. Let's say this is a Nginx container, which is a web server, and the container itself is exposed on port 80. So these containers, they're web servers, they're exposed on port 80. Now, in order for the external world to access this container on port 80, what you can do is you can do a port mapping with the operating system. So on your operating system, you can take any unused port. So in this case, I'm taking port 8000. And I'm kind of doing a mapping between container 1's port 80 and the unused port 8000 on my operating system. Similarly, take 8001, map it to the container 2's port 80, and 8002 for container 3. So now from the external world, someone has a web browser and they hit host 8000. This request is forwarded to my laptop, and it hits my laptop on port 80. And because I have a mapping from my port 8000 to port 80 on my container, the request is forwarded to the container's port 80, and then the page is rendered on the browser. This is a quick, this is how port mapping works with the containers, with the Docker container and your host operating system. Okay, so with that, what I'll do is I'll start with a quick demo of Docker itself. Okay, so I have a MacBook Pro, like Robert had mentioned. This is about 7 years old, and I haven't used it in the last 2 years. So I just wanted to learn about Docker, so I pulled up my MacBook Pro, and it works fine. So I'm really very surprised with the MacBook Pro. Okay, so so this tells me if I have any images. So right now on my MacBook Pro, I've installed the Docker engine. So you can, if you have a MacBook Pro, you can install the Docker engine. Just download the. All you would have to do is you would have to download the. You would download the image file, and it's where's my Docker download? Yeah, Docker image file, and then once you download the file, you can just install this engine. So first thing first, you install the Docker engine. Once you install the Docker engine, you will see there is an icon on the top right, and this tells you that the Docker engine is running. So on your top right, you will see the Docker icon. So in my setup right now, I have an image. So what I'll do is I'll go ahead and delete this image so we start from a clean state. So at this moment, I'm going to delete this image. Okay, so there is no Docker image now. So all I have is a clean slate, just the Docker engine is installed. Now, we have, so Docker has a repository, just like the GitHub repository. There is the Docker Hub. So this, everyone, they post all their images here. So this, you can go to Docker Hub, hub.docker.com, and this would have all the Docker images. It's just like a big repository for Docker containers, Docker images. So at this moment, you can search for anything. You can search for an Oracle image, and you will see there's an Oracle Linux official image. But that's a huge image, so I'm going to get a simpler one. I'm going to start with an Nginx image. Now, Nginx is a web server, so just like IIS or Apache or whatever. So this is a web server, and you can see that there is an official image of Nginx in this Docker Hub. And what I want to do is I want to pull this down from the Docker Hub, and run it on my local machine. So I want to run this Nginx web server on my local machine. So I click on it, and this is the command to pull down the Nginx image, docker pull Nginx, and this pulls the latest Nginx image. And I don't want the latest, I'll go for a specific version of the Nginx image. So what I'll do is I'll specify the version of the Nginx, and I will run it here. So at this time, I'm pulling an Nginx image from the Docker Hub, and you can see how fast it is. I mean, it's already downloaded the Docker, so you already have the image on your local machine from the Docker Hub. Now, if I run Docker images, I should see that I have this image on my local laptop. But I haven't run this. It's just an image sitting on my file system. So what I'll do is I'll go ahead and run this. So to run this, I will run this command. This command is fairly simple as well. So if you look at it, it says docker run, and then you have the name, and you give a human readable name. So you say my Nginx. So this can be any name that you want. And this is the port mapping that I talked about. So the Nginx container exposes itself on port 80, and I'm going to expose it on port 80 on my host laptop also. You can expose it on any unused port on your laptop. I'm just going to expose it on port 80. And this is the image that I want to run. So I run this command. And now I have on my laptop, I have an image, an Nginx image running on my laptop. And I can go localhost, and I can hit localhost. And there you see that it's rendering the page, welcome to Nginx. So, I mean, I didn't have to go through the entire installation process or anything. I just had to pull down that image and run it on my laptop. Now, what I can do is I can go ahead and stop this guy. And once I stop it, this page will no longer be rendered because the container is no longer running, so the site cannot be reached. And if I run docker ps, so this tells me all the containers on my laptop. Docker ps right now is nothing because this container I had just stopped. But docker ps-a will list even containers that are stopped. So it was created a minute ago, but it was exited. So this container still remains. It's just in a stopped state. Now what I can do is I can remove this image completely. I can remove this container. The command for that is docker rm, and then the human readable name of the container that you gave. So now the Docker container is removed. So when I do run docker ps-a, there are no containers in my system. Now, another thing I can do is I can also run commands inside of my Docker container. So let me start this container one more time. So I'm starting my container. But this time what I want to do is I want to run a command inside my Docker container. So I want to start like a shell inside my Docker. So what I do is this exec will execute in an interactive mode. TI is for interactive mode. We are running a shell inside my Docker container. So at this time I'm inside my Docker container. So when I do ls, this is going to give my file system inside my Docker container. So right now this command is being executed inside of my Docker container. I can also say who am I, and this tells me that I'm logged in as root. And again, this is root inside of the Docker container. Now, another thing what we can do is we can, so this is an Nginx server, which is a web server. So I want to look at the configuration file for this web server. So I'm going to run this command that opens up the config file for the Nginx web server. So I'm inside of the container, so I'm running this, and this opens up the config file for the Nginx web server. Now, if you look closely, this config file has a gzip on, but this line is commented out. So this container that is running my web server, there is no compression because gzip is commented out. Now, we want to say, let's say we want to turn on gzip. So we want to use the same container, but we want to turn on gzip. So what we can do is, this is a good segue for me to show you how mapping works. So I will remove this container. So I've removed this container. And what I want to do is I want to show you how mapping works. So what I've done is I've copied that config file onto my local machine. So this is exactly the same config file that's inside the container. I just copied it. The only thing I changed was I uncommented this line so that gzip is turned on. So this is on my local laptop, same file that is inside the container. Now what I want to do is I want the container to use this config file instead of the config file inside of the container. So for that, what I can do is I can run this following command. And I'll show what this command does. And it's basically the same. So you say docker run. We've seen this. We've given the name and then a human readable name. And then this -v denotes volume mapping. So what you're trying to do is you're going to take the file that is on your local system. So this is the file on my local system. And this file is, what we've done is we've uncommented the line, so gzip is turned on. And then this is the file that exists on the container. So we want to map this file instead of this file. The RO stands for read-only, and the -b, this is the port mapping that we've already seen, and this is the name of the image that we downloaded. So at this time, when I do run it, I'm running it right now. So gzip is turned on, so it's going to be compressed. So hopefully this localhost is probably cached, but you will notice that this thing here should show up as compressed. Maybe I'll close this guy, open it again. Yeah, notice that it says content encoding gzip. So right now it is, we are mapping, the container is using the file on our local system. And also, say if we wanted to change the content of this file, like right now it's rendering a page that says welcome to Nginx. We can also change that. What I can do is I can stop this container, remove this container, and very similar to what we did with the config file, I'm going to now map another index.html file. So this is my index.html file, so I'm going to map that to the container. So now when I do run it, this page should show hello from Atlanta. This is from my local laptop. The container is rendering that page. Now I also want to create my own image. So right now this image we just downloaded from the internet. So what I can do is I can build my own image, and for this you need a Docker file. Docker file is very simple. So the first line in the Docker image, the Docker file is where do you want, you start from a base image, then who is responsible for this image. And in this case, what I'm doing is this container, I'm copying the file, this config file from my local laptop into the container, and I'm also copying this HTML, all these files into the container itself. So go ahead and let me run this command, and this should create my own image. So I've created my own image, and I can also do this. I can also push this image to the Docker Hub. So I can log into my Docker Hub. And then I can push this image that I just created to the Docker Hub. So this was a quick rundown on Docker containers.